Hey everyone, and welcome to This Explainer. Today we are going to completely demystify the mathematical architecture that is silently powering our entire digital world. We're talking about number systems, and we're going to walk through some incredibly satisfying solved examples of binary conversions. So, if you've ever found yourself wondering what is actually happening deep inside the microchips of your devices, well, you are in exactly the right place.
Okay, let's take a look at this massive string of numbers. Right off the bat, 10110101. To most of us, seeing a sequence like this just looks like a typo, right? Absolute gibberish, or maybe some kind of barcode glitch. But in reality, this might just be a computer's way of saying hello. This sequence of ones and zeros is quite literally the native tongue of every piece of digital technology you own.
Which brings us to a pretty fundamental mystery. Think about it for a second. If machines don't have fingers to count on like we humans do, how do they process information? Like, how do they actually count? We take our normal numbers for granted every single day, but a computer is essentially just a box of metal, silicon, and electricity. It doesn't inherently know what a 7 or a 9 is.
So here's our roadmap to cracking the secret language. First, the language of computers. Second, decimal versus binary systems. Third, converting decimal to binary. Fourth, converting binary to decimal. And finally, why binary matters today.
All right, let's dive into Section 1, the language of computers, and shifting our paradigm. Let's lay down a quick definition to start. A number system is simply a standardized method of representing numbers within a specific mathematical architecture or framework. And notice I said the word framework. Our traditional way of counting, 0 to 9, feels like this absolute universal truth, but it's really just one arbitrary system. It's a framework heavily based on human biology, but mathematically speaking, it is certainly not the only way to build a number system. Moving right along to Section 2, decimal versus binary systems, hands versus switches. This really gets to the heart of the divide between humans and our machines. See, as humans, we use a base 10 decimal system. And why is that? Well, simply because we evolved with 10 fingers. We count 0 through 9, we run out of digits, and boom, we carry over to the tens place. But computers, they use a base 2 binary system. Their entire hardware architecture relies on billions of microscopic electrical switches. And a switch really only has two possible physical states, right? It's either off, which is represented by a 0, or it is on, represented by a 1. There is literally no middle ground. Okay, let's get into the math. Section 3, converting decimal to binary using the decoder algorithm. To actually pull off this translation, we use a code-breaking algorithm known as the repeated division method. Now, I know that sounds highly technical, but I promise you it is actually an incredibly straightforward and elegant process. Because we are converting our numbers into a base 2 system, the number 2 is going to be the absolute star of the show here. Here's how it works. Step 1, you take any standard decimal number and just divide it by 2. Step 2, record the remainder. Now, because you're dividing by 2, that remainder mathematically has to be either a 0 or a 1. If it's an even number, your remainder is 0. If it's odd, the remainder is 1. Simple as that. Step 3, you take your new answer, your quotient, and just divide it by 2 again. And you repeat this loop until you hit 0. Finally, step 4, you read all those remainders you wrote down, starting from the very last one at the bottom, all the way up to the top. By simply dividing by 2 over and over and tracking those remainders, you just translated a normal human number into a pure binary string of ones and zeros. Actually, before we flip this process around and reverse the math, let's take a quick mental breather with a classic computer science joke. It goes, there are 10 types of people in the world, those who understand binary and those who don't. Okay, now that you know the basics, this is actually hilarious. Let me explain. If you take the human number 2 and divide it by 2, you get a quotient of 1 and a remainder of 0. Divide that 1 by 2, you get 0 with a remainder of 1. Read it from bottom to top, and the number 2 in binary is written as 1, 0. So the joke isn't saying there are 10 types of people, it's saying there are 2 types of people. You gotta love nerd humor. All right, Section 4, converting binary to decimal. Let's reverse the translation. Reversing this whole process becomes incredibly intuitive once you grasp the secret underlying its structure. And that secret is what we call the anchor of place values. Just like our everyday decimal system relies on the ones, tens, hundreds, and thousands places, binary uses its own specific place values. But instead of multiplying by 10 every time you move to the left, in binary, because remember it's base 2, the place values simply double. Take a look at this table. The top row shows those doubling place values, reading from right to left. 1, 2, 4, 8, 16, 32, 64, 128, and it just keeps going. By anchoring a binary number, let's just use our joke number from earlier, 1010. Under this chart, decoding it takes literally seconds. You line it up starting from the right. So we have a 0 in the ones place, a 1 in the twos place, a 0 in the fours place, and a 1 in the eights place. You simply add together the values of the columns where a 1 appears. So an 8 plus a 2 gives us a perfect decimal 10. It is seriously that easy. The computer basically says, hey, turn on the 8 switch, turn on the 2 switch, and boom, we get the number 10. Which brings us to our final section. Section 5. Why binary matters today. The big picture. Like, binary is the absolute foundation of the digital world. We've done the math, we've walked through the examples, but bringing this back into your everyday reality shows why this framework is so completely vital. Every single thing you do on the device you're using to view this explainer right now is powered by this exact math. Every text message you send, converted to binary. Every single pixel of every photo you double tap on social media, dictated by a binary value. The very audio of my voice right now, it is being rapidly calculated and rendered through these exact binary conversions, happening billions of times per second across microscopic silicon switches. It's wild to think about, but it is the invisible thread connecting all modern human communication. So I want to leave you with this provocative thought to ponder today. If we can build the entire modern internet, I mean, every streaming service, every video game, every piece of global financial software, all from a simple mathematical framework of true or false, ones and zeros, what other unimaginable complex systems might be waiting out there for us to decode? Keep that in the back of your mind the next time you tap a screen. Thanks so much for joining me for this explainer, and as always, keep questioning the world around you.